today's episode, we are looking at uniform circular motion under centrifugation. When we talk about centrifugation, it's a method used to separate two immiscible liquids or used to separate fluids. And then there are forces which act in centrifugation. We can talk of centripetal force, centrifugal force, buoyant force, we have frictional force. But today we are looking at centripetal force and centrifugal force. As it bears its name, centripetal, center. So it means that this force acts toward the center of its circular motion, whilst the centrifugal also acts away from the center of its circular motion. We have these two forces and they are acting in centrifugation. Now let's look at the following formulas. We have angular velocity, which is 2 pi f. The angular velocity as shown over here, 2 pi f. The f over there is the frequency. That's the number of rotation per second. Also, we have the linear velocity. There is a velocity which is acting over here, and this velocity is linear. During the centrifugation, the velocity over here is linear, which is also equal to 2 pi f times r. The r is the radius. The radius, that's the distance of the particle from the axis of rotation. From the axis of rotation, the distance between the particle in centrifugation and the axis of rotation is the radius. So the linear velocity is also giving us 2 pi f times r. By substitution, instead of 2 pi f, we can substitute by omega, which is the angular velocity, omega. So we are going to get the linear velocity equal to omega r, where the omega is the angular velocity and then the r is the radius, which is the distance of the particle from the axis of rotation. Let me draw your attention to this. We have a force, and we know that force is equal to mass times acceleration. Force is equal to mass times acceleration. And here we have radial acceleration or centripetal acceleration. It's the same, radial acceleration. The acceleration over here, which is radial acceleration, is the same as the acceleration in force, which is mass times acceleration. Mass times acceleration. So mass times radial acceleration, they are the same. So the force is equal to mass times radial acceleration. Radial acceleration, as we know over here, is equal to v squared over r. V, which is the linear velocity, we know is also equal to omega r. So by substitution, we can replace v by omega r. And replacing v by omega r, we are going to get omega r all squared over r. Omega r all squared over r. So multiplying, squaring through to open the bracket, we are going to get omega squared r squared over r, as you see over here. Omega squared r squared over r. Now the denominator, which is r, we take out one of the r from the numerator, which will give you omega squared r, which will give you omega squared r. So from radial acceleration we can get these two formulas, which is radial acceleration or absolute radial acceleration is equal to v squared over r or omega squared r. Now let's look at the centripetal force or the centrifugal force. Now from this circular path you can see the centripetal force moving towards the center of the circle, while the centrifugal is pointing out of the circle. But then we have point of inertia, the point at which they are starting or they are beginning. That's the point of inertia. Now, as I said earlier, that force is equal to mass times acceleration, which can also be the radial acceleration. So we have the force over here is equal to m, which is the mass, times v squared over r. Now let's look at this place. V squared over r, which is the radial acceleration, is rather v squared over r. So instead of radial acceleration, we replace it by v squared over r. So now our centrifugal force F is equal to mass times the linear velocity squared over the radius. And we said the radius is the distance between the particle and the axis of rotation. So our centripetal force is equal to mass times, in place of v as we did earlier, we got angular velocity squared, angular velocity r all squared over r, where you square both the angular velocity and then the radius, giving you angular velocity squared r squared over r. So the denominator will take one of the r, then you get force is equal to mass times angular velocity squared r. So these two formulas can be used to calculate the radius, the angular velocity, the mass, and in all the centrifugal force at which the particle is rotating. Let's look at this question. If a human centrifuge in 9 meters in radius, at what speed must it rotate to produce 3g of acceleration? Now we have the radius to be 9 meters, and the question is requesting for speed, which is the velocity. And you can see that we have 3g in the question. The g is not in grams. We are talking about acceleration. So the 3 is multiplying the acceleration, and the acceleration is constant, though it's not given, but it's constant, which is 9.8 meters per second squared. Now we have 3 parameters, which are velocity, radius, and acceleration. So we have to pick a formula that contains all these 3 parameters, and we can choose radial acceleration or absolute acceleration, which is equal to v squared over r. We are looking for v, and for that matter we have to make v the subject. So you will get v squared is equal to radial acceleration times the radius. Now let's do the substitution. After that we see how best we can omit the square. So by substitution, v squared is equal to 3 times the acceleration, which is 9.8 meters per second squared, times the radius, which is 9 meters. So when you multiply this, you are going to get 270, and the unit, you have to multiply the unit, which is meters times meters will give you meters squared. So you are going to get 270 meters squared per second squared. So to omit the square, you have to take square root of both sides, and we are going to get V is equal to square root of 270 meters squared per second squared. So let's get V is equal to square root of 270 meters squared per second squared. Now, since the square root is taking everything, you will get square root of 270 times square root of m squared over square root of s squared. Now, let's simplify that of the unit. Square root will cancel the square, that is, you get m. Also, the denominator, square root to cancel the square, you get s, that is meters per second. Now you will get V is equal to 270 meters. So you will get V is equal to square root of, so simplify 270 and leave your answer in the comment section. Thank you.